Welcome to another episode of the Back to School Shootings podcast. My name is David Reedman. I'm the creator of the K-12 School Shooting Database. This week, there was a story in the news that connects to work that I've been doing for almost 2 years at this point. There was a story last weekend out of Baltimore County, Maryland, where an alert was sent to police saying that there was a student with a gun on campus. When police got to the school, they approached a group of students at gunpoint, made them get on their knees, handcuffed them, searched their bags. And at that point, they realized that an AI system, which is supposed to detect images of guns on the school's camera system, had identified a bag of Doritos chips as a gun. At that point, the officers laugh. They say, "Man, it looked like this system flagged you guys for eating chips." But then there's a really scary part of this. The officer goes, "This product shouldn't be in schools." And then he says to the kids, these are a couple of teenage football players who are waiting to get picked up after football practice. The officer says, "It's a good thing you guys didn't run because this would have been way different." And that's the problem that I've been talking about and warning about for 2 years now, is when officers get sent to a school, whether it's a faulty panic button, an AI system that thinks that there's a shooter on campus, or a swatting hoax, those officers think that they are going to the biggest call of their life. They are full of adrenaline. They're going into the schools with guns drawn. We've already seen mistakes that happen at schools when officers fire their guns during swatting hoaxes, when there's nobody with a gun at the school. And in this case, it's just lucky that these teenage students were able to keep a cool head during the situation. They didn't get alarmed or panicked. They just sat there quietly, put their hands up, didn't talk back or resist. And the officers were able to figure out that this was all an error based on the school's security monitoring software. So I want to start this description back in March 2024. That's actually the first article that I wrote specifically about AI security products being sold to schools. And what was important about this is that schools hear AI, but they don't really know exactly what that means or what's going on inside the black box. And in the case of this product in Baltimore County, it's a visual analysis program, which is comparing images that it sees on the camera to images in training data. And if there is a match in the clusters of pixels between what shows up on the school's camera versus something that it was trained at to recognize, then the program will assign a percentage, and based on a threshold, that percentage will then generate either a human review or an alert to police. This is not new technology. This actually is something that started in the early 2010s at Stanford's Human-Centered AI Lab. So Dr. Fei Li was the first person to be able to accurately create a program that could classify images. And it was just telling the difference between pictures of cats and dogs. And so to get a computer vision program to just classify the difference between pictures of cats and dogs correctly, it took 10,000 people coding images, and they had to code 1 billion images to create the training data. And this took 3 years just to create an image classification that could accurately tell the difference between a cat and a dog. And why that matters here is because the system used in Baltimore and these image classification systems that are used to detect, for example, a gun on video, are using this 2010s technology, which is giving a program a large set of training data and then having it decide a probability that some new piece of information it's seeing is a match with that training data. And the biggest decision that needs to be made in this is, what is your threshold? Because if you look at a picture of a gun that's held against a background that has distinct colors, so every part of the gun shows up, the computer system might be 99% sure that it's a gun. But if it's turned slightly or it's obscured slightly, maybe it's only an 80% chance that it's a gun. But if you take similar objects, like maybe a cell phone or an umbrella or a stick or a shadow, depending on their orientation to a person, they could score as 90% or 95% likely of having a gun. So the important thing about image classification is the computer doesn't know what a gun is. It knows what millions of training data images of guns are, and it's trying to assign a probability that what it's seeing on the image is matching what it was told to do in the training data. And that's very different from a system like ChatGPT or Google Gemini or Claude. Really the first generation of what we think of as AI models today is what was created in the 2010s. And that was called a supervised image classifier. And that was, you get training data where the things are labeled with what they are. That could be cat and dog. And you give the system millions of those labeled images. And with enough of those labeled images, then it will be able to accurately classify something into simple classes like cat and dog. Then in 2014, there was a second generation, and that was when CNNs were created. That's a convolutional neural network. And that is actually creating a iterative learning process where you're providing images and it is improving after each image. And it's understanding more about which features to pay attention to. So that first generation only works if you tell it what the images are. By the second generation, with the neural networks, it's starting to learn and adapt and understand. Into the third generation, around 2017 or so, this is now when you start having pre-trained models, where there's a model that has been given lots of different types of information, and then it's able to use that to generate a new output. And then in 2020 is the fourth generation, where there are now these foundation models, where they're given massive amounts of information, and they use then the neural network for self-supervised learning. And this is the first ChatGPT, the first DALL-E versions. That's in 2020. 2022 is the fifth generation or so, and that's where you start getting this multiple types of large language models. And they are general purpose models that can do many different types of things beyond specifically what they were trained for. And ChatGPT was really the model that shined as being a general purpose model. And that's in 2002. And then the sixth generation, which is what we're seeing now, which was developed in late 2023 into 2024, are these multimodal models where you can give it text and images and videos and code, and it combines that with different tools and reasoning. And that's where, with one of these multimodal models, you can just upload a random cell phone picture of a scene and say, what's going on? And it's able to look at that entire context of your scene and say, that that's what is appearing in this. But going back to these image classifiers that are being used at schools, those are essentially the first generation of either supervised image classifiers, where you're giving a labeled training data set of what guns are, or the very elementary convolutional neural networks, where you're applying some learning to the sole task of classifying images. So what happened in Baltimore County, we hear AI, we think cutting edge, but that was really technology that is 10 to 15 years old that's being sold to a school under the name of being cutting edge AI. So anything that is solely doing image classification is pretty old technology at this point. And that immediately makes you think, when there are things like ChatGPT available now, why aren't these companies then pivoting to use a general purpose model that could understand the entire context of the scene? The problem with that is the cost. The cost is significantly different from the compute that's needed to run an image in a sole purpose image classifier. It's still a lot of data, it's still a lot of compute, but it's nothing compared to what it takes for a general purpose model to evaluate an image. So if you imagine a company that has contracts all over the country, say they have 50,000 camera feeds that are at schools, and on those cameras, they're taking 2 frames per second. The camera's actually recording much faster, but you just take 2 frames per second because that's going to give you kind of a manageable amount of images to process from different angles. Well, 2 frames per second on 50,000 cameras is 8.6 billion images that you need to analyze per day. And OpenAI has some enterprise pricing that's online. Analyzing 2.6 billion images, if they're low res, you're at about $6.7 million a day. If you're analyzing high res, which is what you would need in that Baltimore County case to see a gun in a dark courtyard in the evening hours when students are waiting to be picked up after practice, you're looking at about $26.5 million per day just for the cost of having ChatGPT analyze those images. So that is not at all viable for these companies. So that's why they're using 2010, 2014 tech, because it can kind of work. It can create a minimally viable product, even if there's a lot of error and inefficiency in it. And they're able to run it at a much lower compute cost. But it's still very costly to be analyzing literally billions of dollars per day at scale. And this shouldn't catch anybody by surprise. So in June 2024, so now almost 18 months ago, CNN reached out to me, and CNN said, "Can you write an article about AI and school security?" Didn't give me any other instructions. Said, "Go wherever you want with this." So I put together about a 2,000 word op-ed for CNN, and I focused on this being kind of a guide for a school administrator or somebody involved in procurement at a school who's looking at and considering buying some sort of AI technology, because it is not just these visual camera systems. There are AI powered metal detectors now. There are these classifiers for CCTV. There are acoustic monitors. There are AI powered doors and gates. There are systems that are looking at student records and social media threats. There are also AI systems that are trying to do real time facial recognition to identify whether there's an intruder, whether there's unauthorized people inside of the school, or just to do student accountability to see where kids are going throughout the day. So I wanted to focus this article on what AI can and can't do. What are the things that work well or doesn't work well with AI? And I talked about visual gun detection as one of these, where it just does not work well because when you have low resolution security cameras or even high resolution security cameras that are looking at large areas, you're not getting a good enough image to be able to really see the details of a gun versus all of the other things that can look like a gun. And that means that you need to use a pretty low probability threshold, and that's going to generate a lot of false alarms. And we've seen false alarms happen at schools. One happened in Texas when students were taking the SAT tests, and all of a sudden there are hundreds of police officers with guns drawn running into the school looking for an active shooter. AI also is very costly. These are, multi-million-dollar contracts. The Baltimore County contract is more than $3 million based on the open source information that's available there. And so this all kind of comes together with this situation in the Baltimore County school of where do we go from here with AI and schools? And the issue is that if something is sold as giving a concrete answer, but it actually generates a probability, that's always going to be a problem for school security, because a school administrator or a police officer wants to know with certainty that there's a weapon or not. They don't want to know a maybe, because a maybe results in a Doritos bag being flagged as a gun and then students being held at gunpoint on campus. So if AI is sold as a perfect or fail-safe product, then you're creating this whole chain of false confidence in the validity of the alerts that it gets. This also extends to AI metal detectors. With a metal detector, you have the properties of physics that are going to decide whether a metal activates the system, and based on how much metal there is, you can get some readings based on the sensitivity of the metal detector's kind of functional hardware. So if you have a multi-zone metal detector, where it's basically a couple metal detectors stacked on each other, you could come up with some probabilities that detecting this much metal in this region is likely to be a weapon. But it doesn't know that it's a weapon instead of a metal water bottle. It doesn't know that it's a weapon instead of a laptop, because anything that has the same amount of metal and is in the same place, it cannot tell whether it's a weapon or just another metallic object. So AI can give you a prediction based on a huge amount of data of metal walking through a metal detector, but it can't fundamentally change the rules of physics. And it can't change something that detects metal or not metal, or has some sensitivity to the amount of metal, and suddenly decide that something is a water bottle versus a gun. So we've got to get realistic about what AI can do, what it can't do. And right now, we're at this point where I think there's a lot of concern about an AI bubble kind of across the industry. ChatGPT 3 and 4.0 were incredible. ChatGPT 5 has been a letdown. But every one of these AI systems is using more and more data, has more and more infrastructure going into it, has greater costs associated with operating the business. Is that going to be viable, or is this going to fall apart? And schools need to be thinking about the same thing, because schools are making multi-million-dollar investments into companies that don't have any oversight, don't have to publish reports about errors, don't have to publish information about their accuracy, don't publish information about their costs. So a school could be entering into a multi-year contract with a vendor that only has a month worth of money left to operate. Schools don't know any of this. They don't know the financial standing of the companies that they're dealing with. They don't know the accuracy of the products that they're buying. And unfortunately, they're not being told about the serious risks that if you use a technology from 10 or 15 years ago that has a lot of limitations in the way that it can classify images, that not only will these things happen, they will continue to happen. And unfortunately, there is a chance, and it's an increasing chance as more schools adopt systems like this, that in the confusion of arriving on campus and thinking that there's somebody there with a gun, an innocent person is going to be shot and killed. And risk management is a topic that I like to think about. And a very simple way here is, if there is no gun on campus, there is no risk to any student. if there is a false alert that there's a gun on campus and police respond with guns drawn, there now is a risk of death or serious injury to every single person on that campus. So this is not harmless technology at all. We are taking situations where those students in Baltimore faced zero risk of being shot at their school that day. Once the alert was sent saying that there's somebody with a gun, those students faced the very real risk of being shot. Now, to dig a little more into the incident in Baltimore, I have my two favorite assistants who are Google robots, but they do a very good job of explaining text. So while image classification has a lot of issues with difficult things like differentiating a gun from a cell phone in low light, something that AI is absolutely incredible at is summarizing information. So check out the summary of what happened in Baltimore, and I'll talk to you all next week. Thank you.
Welcome to the deep dive. Today we're really getting into something critical. It's about AI in school security. And we're not starting abstractly. We're jumping right into a specific, pretty alarming incident out of Baltimore County, Maryland. Just imagine this. 4 high school kids, they're waiting outside after football practice, just, hanging out, eating snacks.
Yeah. Seems totally normal.
Right.
But then, suddenly, things get terrifying. Police show up, guns drawn. They force these kids onto their knees, handcuff them. Why? Because the school's AI gun detection system sent out a critical alert, a weapon alert.
And here's the kicker, the part that honestly should make everyone pause, the supposed weapon.
It wasn't a weapon.
No, it was a bag of Doritos. You can even hear it on the Bodycam footage. The supervisor looks at the AI's image and says, that looks like a chip bag. Then the officer has to explain it to these kids who are clearly shaping up. He says, basically the camera system picked up the way you guys were eating chips and thought it was a gun.
And that incident, that's really our starting point for this deep dive. We want to look past just how absurd it sounds, because this isn't just some, minor tech bug. It really highlights the core tension here. You've got AI, which works on probability mathematical guesses, essentially.
Right, maybes.
Exactly, maybes. And then you have the demand for security, especially in schools where people want, needs certainty, life or death certainty. So our mission today is to unpack this. Look at the tech limitations, the, frankly, huge costs involved, and the legal fallout when a chip bag triggers this kind of response.
Okay, let's start with those costs, because the money spent in Baltimore County, it's pretty eye-watering when you see the result. The school district spent $2.6 million over 3 years for this system.
$2.6 million.
Yeah, and think about what that means in, real terms for a school. We ran the numbers based on typical starting salaries. That $2.6 million could have paid for about 25.5 new full-time teachers. Right, so you're trading over 24 people educators focused on kids for an algorithm that thinks Doritos are dangerous. It feels like a really warped priority.
It fundamentally is. And that comparison really throws the risk assessment into sharp relief, doesn't it? I mean, let's be blunt. A bag of chips poses absolutely zero risk of a student getting shot. Zero.
Obviously.
But police pointing real firearms at students because of a faulty AI alert, that creates a massive immediate risk, very real risk, that a kid could get hurt or worse. So the irony here is just stark. This hugely expensive system, bought to make schools safer, directly led to 4 students being put in a dangerous, terrifying situation and made them less safe. And this is why you, listening, should care, even if you're nowhere near Baltimore. This model spending big money on, often outdated tech, it's happening all over. When the systems being sold can't reliably tell the difference between, a snack and a handgun, we really need to pull back the curtain and understand what's actually going on inside that AI.
Exactly. So let's do that. Let's try to get inside this black box. Why did it fail so badly? The source material we looked at makes a really key distinction about AI generations.
Yeah, this is important. The kind of AI software often sold for this purpose, visual gun detection in schools, it's frequently based on what you call second-generation AI. Think late 2010s tech. Its main job is pretty narrow image classification, like, is this picture a cat? Is it a chair? Is it potentially a gun? That's it.
So it's a far cry from the AI we hear about now, like the big large language models, LLMs, things like ChatGPT.
Oh, completely different leagues. We're talking maybe 6th or 7th generation LLMs now. Those can understand context, relationships, nuance. The 2nd-gen stuff, it's much more limited, almost blind by comparison.
Okay, so how does this older tech see then, if it's not like us?
Right, it doesn't see conceptually. It's all about math. It breaks down the camera image into pixels, right,
Huh?
and assigns numbers to things like brightness, color for each pixel. Then it looks for clusters, patterns of these numbers that match patterns it learned from its training data. Images labeled gun, images labeled not gun. It calculates a probability score based on those pixel patterns.
So it's not saying, yes, that's a gun. It's saying, based on the pixels, there's an X% chance this pattern matches what I've learned is a gun.
Precisely. It only gives you a maybe, a probability score, and that's why it struggles so much in messy real-world places like schools. You could have, say, a rolled-up umbrella catching the light just right, its shape,
Wow.
the reflection. It might score really high, maybe 90% probability of being a weapon to the AI.
Okay.
But then a real handgun, maybe partially hidden by a jacket or inside a bag, might only score 60% because key pixels are obscured. So the company selling the system has to decide where to set the alarm trigger, what probability threshold. Maybe they set it at, say, 85%.
So anything above 85% probability triggers an alert to the police or security.
Exactly. And that's where things get tricky.
And that brings us back to the Doritos, right? How does a chip bag hit that 85%? There are these things called attribution masks.
Yeah, attribution masks are basically tools analysts use to see which pixels the AI is actually paying attention to when it makes its decision. Think of it like a heat map over the image.
Okay, so it shows what parts of the image made the AI think gun.
Correct. For a handgun, the AI is usually trained to look for pixel patterns corresponding to the grip, the trigger guard area, maybe the line of the barrel or slide. Very specific geometric features it learned from training photos.
So the Doritos bag.
Well, think about it. A crinkly, shiny, maybe folded bag. You get sharp edges, high contrast between the shiny parts and the print, specific angles. If a student is holding it, maybe obscuring part of it, those shapes and reflections could, mathematically, look very similar to the pixel patterns the AI associates with a pistol slide or the grip.
So the algorithm just sees the pattern it was trained on, even though the object itself is totally wrong?
Exactly. It finds enough gun-like pixels, mathematically speaking, to cross that probability threshold. It doesn't have the common sense, the context, that a modern AI or a human would have.
It can't tell it's lunchtime, they're standing by a trash can, they're actively eating.
None of that. It just sees the pixel data and runs the numbers. High probability score. Alert.
And we know these scores can swing wildly. The source mentioned a demo. A clear view of a weapon scored almost 100%.
Yeah, 99.7% probability. Very high confidence.
But then just slightly obscure that same weapon.
The probability plummeted down to 87%.
Okay, so if you need to catch that real but obscured gun, you have to set your alert threshold low enough, say 85%.
Right, but the consequence is...
You're going to get flooded. Anything that scores in the high 80s triggers an alert. Chip bags, umbrellas, maybe tools, phones.
Lots and lots of false alarms. Which naturally leads people to ask, well, why not just have a human check the alert before calling the police? Put a person in the loop.
That seems like the logical solution.
It does, until you look at the sheer scale of it. It's just not feasible in most cases. Take a big school district, maybe 50,000 cameras. Even if they're only recording at, say, 2 frames per second.
Okay.
That's 8.6 billion images generated every single day.
8.6 billion.
Billion. Now, let's be really generous. Let's say the AI is incredibly accurate, like 97% accurate.
Which seems optimistic based on the Doritos incident.
Very optimistic. But even then, that 3% inaccuracy rate means humans would need to review about 1.5 million images daily.
1.5 million alerts to check every day.
Yeah. Could you imagine the manpower, the cost, the fatigue? Mistakes will happen. It's just not a practical solution at that scale.
Okay, so human review isn't really the answer. And that brings up another point. Why are schools using this, seemingly flawed second-gen tech anyway? Why not the better stuff?
The economics.
Yeah.
Why not use the fancy 7th-gen LLMs, the ones that might understand context better?
No.
Simple answer. Cost. We actually did a rough calculation based on current enterprise pricing for that level of AI analysis. To analyze those same 50,000 camera feeds constantly with a sophisticated, context-aware LLM, you'd be looking at an annual cost of around $9.67 billion.
Wait, billion? With a B?
Billion with a B. $9.67 billion. per year.
That's insane. How does that compare to a school budget?
For a large district like Baltimore County, that's roughly 3.5 times their entire annual operating budget.
Okay, so it's completely unaffordable.
Completely. And that's why schools end up buying the cheaper, older, narrow AI systems, the ones based on probability that flag chip bags. The better tech exists, but it's financially out of reach for this kind of mass surveillance application right now.
So millions are spent on tech that generates false alarms, doesn't have human review, and doesn't even address the real problem.
Well, that's the other crucial point from the research. What is the most common scenario in school shootings? Studies looking at thousands of incidents suggest it's often not some external attacker breaching the gates. More commonly, it's a student, often a teenager, who's been carrying a weapon, maybe habitually, in a backpack. And then something escalates. A fight, maybe? Exactly. And shots are fired. Now think about it. Does this kind of camera AI, looking for visible guns, stop that?
No, the gun's in the backpack.
Right. And what about metal detectors? Maybe they catch it, but often they just lead to huge lines, kids losing class time, and determined individuals find ways around them. These systems often miss the core issue.
They don't stop the weapon from getting into the school in the first place? Concealed?
Precisely.
Yeah.
So you have this massive investment in tech that might not even be targeting the most frequent threat vector effectively, and it creates these dangerous false alarms.
Which loops us back to Baltimore and the legal side of this. This isn't just about tech failure or wasted money anymore. It feels like a legal mess waiting to happen.
It absolutely is. We're seeing what happens when police action is triggered by an algorithm's probability, not by human observation or verified proof. It raises some really serious legal questions.
Like what?
Okay, first, false pretense. Let's play devil's advocate. Imagine the police did find something illegal during that Doritos stop. Say, drugs, or even a real weapon totally unrelated to the AI alert.
Oh, okay.
Could the entire case get thrown out? The defense would argue the initial stop, the reason the police interacted with the students at all, was based on a machine error, a faulty premise.
The fruit of the poisonous tree doctrine.
Exactly. If the stop itself was illegitimate because it was based on a malfunctioning algorithm mistaking chips for a gun, then any evidence found during that stop could be inadmissible.
That's a big vulnerability. What else?
Well, the immediate harm. These kids were detained at gunpoint because of a computer glitch. That's wrongful detention.
Yeah.
Can they sue the school, the police, maybe even the AI company for the trauma, the emotional distress? That fear was real, caused directly by the system's failure. Seems like a strong basis for a civil suit.
Yeah, you think so. And what about in court, if charges were filed based on an AI alert?
Now it gets really constitutionally murky. Think about the Sixth Amendment, the right to confront your accuser. Who's the accuser here? The algorithm. How do you cross-examine lines of code?
You can't.
Right. So does the defense get to demand access to the AI's proprietary software, its training data, the exact probability score, and threshold settings? How accurate is this witness, really? This pushes right up against the problem of algorithmic transparency or the lack of it versus fundamental due process rights.
It's a legal minefield.
It really is. And what those students in Baltimore went through, it's not just an anecdote. It's showing us the erosion of due process happening right now. We all desperately want schools to be safe. We want that certainty. But we're outsourcing these incredibly high-stakes decisions that lead to police drawing weapons to outdated AI systems that only offer a maybe. The machine guesses based on pixels, and humans react with potentially lethal force. That's the reality.
So when that machine's guess is wrong, and a kid ends up handcuffed looking down the barrel of a gun because they were eating chips, the question for every school leader, every policymaker has to be, what level of machine error, what level of uncertainty are we willing to accept when the price of being wrong is potentially that high, when it's a child's life or well-being on the line?
That's the fundamental question.
And for you, our listener, maybe the takeaway is to really understand the difference we talked about, that gulf between simple, older image classification AI and modern context-aware AI. And armed with that, start asking the hard questions if these systems are proposed in your community. Ask vendors, what are your probability thresholds? Can we see independent real-world data on your false positive rates? Don't just accept the promise of safety. Demand proof, because false confidence isn't safety at all.